Good evening, students. Welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss polygons and circles. And in this video, we shall just talk about equilateral triangle and circle. These polygons and circles is a video playlist. It's going to be a video playlist that will have several videos. Please, the website that you need to go to is, in addition to my website, it is recommended that you go to this website, www.polygonsandscircles.appspot.com. The website will contain the videos, the link to the videos, the notes, the calculators, as well as links to other resources. The New York Regents exam in geometry, common core exam for geometry by the state of New York, and the California past questions, the state of California, their past questions on geometry. So please, it's very important. This website will contain all of it. Also, it is important that you go to my website as well, www.samuelchukwuemeka.com, or you go to the mobile friendly version, www.chukwuemeka-samuel.appspot.com. So under the mathematics section, you click on geometry. It will also contain the link to the videos, the notes, and the resources. We are going to discuss regular polygons. That is actually what we are. The polygons and circles we are talking about would be regular polygons and circles. In this video, we shall discuss equilateral triangle. Because when you talk of a regular polygon, a polygon is any closed figure with straight sides. Okay? A two-dimensional figure is closed and it has straight sides. So you have, when we talk about triangle, a regular polygon, it's rather than say regular triangle, we say equilateral triangle and circle, and then circle. Okay, so we are going to talk about the equilateral triangle inscribed in a circle and the circle inscribed in an equilateral triangle. And we shall find details. We shall find the details from those. So the first case 1. We talk about equilateral triangle inscribed in a circle. Equilateral triangle inscribed in a circle. So I hope I draw this well. I am not an artist, so I hope you bear with me. Okay, so we have, let's look at this. We have, if we have a circle and we have an equilateral triangle inscribed in the circle. So, which means this tells you, the inscribing in the circle tells you that the vertices of the equilateral triangle they all touch the circumference of the circle. okay, the vertices of the equilateral triangle, they touch the circumference of the circle. Okay, these three vertices. So I would like you to take down as I discuss. I also have all this. I also have this in the notes. Okay, I also have it in the notes. But as I'm talking, it's good you take down. So let's say that this is the center of the circle here. Let's say that this is the center of the circle. Okay, let's call this the center of the circle. And the first thing to note, when you have this, we say equilateral triangle inscribed in a circle. So this is equilateral triangle. Has three congruent sides and three congruent angles. Okay, each angle in the equilateral triangle is 60 degrees. So when you say this equilateral triangle inscribed in a circle, another way to say this is, or you can say, or circle circumscribed. Circle circumscribed about an equilateral triangle. Equilateral triangle. So you say the equilateral triangle inscribed. Okay? In all these polygons and circles, we mean regular polygons. That is what we mean. Regular polygons. So you might want to add regular polygons and circles. So we start with triangle. Okay? Triangle, that is the easiest regular polygon. The smallest regular polygon is a triangle. Because the polygon has to be closed. Okay? Has to be closed and it has to be straight sides. A polygon, two-dimensional figure, closed with straight sides. So when you have to close straight sides, you get triangle is the minimum. So and we say, rather than saying regular triangle, okay, we say equilateral triangle. But if you say regular triangle, we do say regular square or regular, because the regular quadrilateral is the square. Okay? The regular triangle is the equilateral triangle. Then the regular quadrilateral, which we shall do in the next video, is the square. That one has several ACT questions. They like asking it a lot. Okay? Then you have pentagon, hexagon, heptagon, and the rest of them. So I want us to start with this minimum here. So we say equilateral triangle inscribed in a circle, or a circle circumscribed about an equilateral triangle. That is the way we say it. Okay, so the first thing you have to note here, is that you write down the center of the triangle, the center of the equilateral triangle is the center of the circle. Okay, the center of the equilateral triangle is the center of the circle. That's the first thing you should note. Number two, let's say, okay, if we have, anytime you see R, let's call it radius of the circle. Radius of the circle. B, let's call it the base of the triangle. Base of the triangle, which means any side, okay, or any side, because it is an equilateral triangle, so it doesn't matter. It's the base of the triangle or any side. If we see H, let's call it the perpendicular height. Perpendicular height of the triangle. Okay? If we see D, let's call it diameter. Diameter of the circle. Diameter of the circle. If we see A, let's call it apothem of the triangle. Apothem of the triangle. Apothem. If we see A subscript T. Please, I want you to get used to this, because anywhere you see R, you just know I'm referring to the radius of the circle. Okay? If you see me write D, I mean the diameter of the circle. If you see me write A, that means the apothem of the triangle. So I want you to, this is the letters I'm gonna use. If you see A subscript T, that is area of the triangle. Area of the triangle. And then if you see A subscript C, area of the circle. Area of the circle. Okay. So let's now, I'm gonna use yellow as needed to illustrate some of these terms. So assuming you were given the radius, okay, say you were given the radius of the circle R, and you have to find every other thing, okay, and once it doesn't matter, once you get one thing, they just need to, when they ask you the question, they can give you just the radius of the circle and ask you to find the area of the triangle, or they ask you to find the area of the circle, or they ask you to find the ratio of the area of the triangle to the area of the circle, and then you have to find the rest. All they need to give you is just one parameter. They give you one parameter, they can give you radius of the circle, they can give you diameter of the circle, they can give you apothem of the triangle, they can give you height of the triangle, they can give you base of the triangle. You have to find the rest. How do you do that? Okay, so they give you this radius of the circle. Let's assuming they give you that. Okay, once you know the formula for it, the rest you can find it. So notice that here the radius of the circle is either from here to here or from here to here. These dotted lines, okay, that's the radius of the circle. So you will see that this is the radius of the circle R here. R. I know this is not drawn to scale, okay? It is not drawn to scale. I want you to know this. In geometry, we have to follow theorems. Don't just look at it physically and assume. We don't do that in geometry, no. You look at the question that you were asked. They will say that this is the center of the circle. They can say center C. Let's call it center O, because, let's call it center C. Center C, circle C. Okay? Circle C. Or you can just say, you can just write it like this. C. Circle C, which is the center of the circle. C is the center of the circle. Center of the circle is point C. Okay, so we don't assume in geometry. Whatever we do is we don't just, sometimes it's not drawn to scale and they say. So we solve geometry based on the questions that they said. Okay, from the questions that we were given, that is what we use. And the theorems that we know, that is what we use to solve geometry. So they give you this, the radius of that. And you will find out here that this is like a perpendicular. This is perpendicular to this face. Okay? We call this the apotem. This is the A. Apotem. Here. Apotem is the distance from the center of the triangle to the side of the triangle, the perpendicular distance. Apotem is perpendicular distance, apotem of a polygon, apotem of a regular polygon is the distance from the center of the polygon to the perpendicular distance, please put perpendicular distance, okay. Apotem of a polygon is the perpendicular distance from the center of the polygon to a side of the polygon, because the polygon has, a regular polygon has congruent sides. I probably didn't say regular, okay, let me repeat it again. The apotem of a regular polygon is defined as the perpendicular distance from the center of the regular polygon to a side of the polygon. Okay. Remember, I said regular polygon. What we are discussing now are regular polygons for now. So this is what we call it the apotem. And remember, we say that the center of the triangle is also the center of the circle. So that is the center of the circle. It is also the center of the triangle. Center of the triangle also. Still point C. Okay, point C. Okay, so if we are given only that R, right? We're just given the radius. And remember, this is the base. And this is the perpendicular height. This is the perpendicular height, the whole thing here. If we extend up to this here, then from here to here is our height, is our perpendicular height. The height of the triangle. So the question you now ask yourself is, what are you now going to do? Because we want to find, we are only given the radius of the circle. And then we are now required to find the rest. We do know that the angles in an equilateral triangle, okay, each of the angle in an equilateral triangle is 60 degrees. That's what we know. And we also know that this, this is the radius, this is the radius, okay? This is also the radius here, from here to here. So these are radii here. We also know that these are here, this angle is equal to this angle, an isosceles triangle. Let's assume we call this A, if we call this maybe ABC. ABC. So, well, ABD, because we have center C. We do know that ACD is an isosceles triangle. ACB is an isosceles triangle. BCD, triangle BCD, they're all isosceles triangles. This is actually, because you have the whole thing here as 60 degrees. You have the whole thing here at 60 degrees. But you're getting from the center to this. So this actually bisects this. When we talk about this, based on the principle that, based on the fact that you have this from the center of the circle to this vertex of the triangle. Okay? I mean, from this, you'll see that the radius bisects the radius bisects the angle at the vertex. It bisects the angle at the vertex. So essentially, you have something like this. You now have something like this. This is the radius, okay? This is the apothem here. This is a base, half of the base. So I'm going to call this B over 2, B over 2. I call it B over 2. And you have this as 30 degrees, 30 degrees. So just kind of take a look at that for a moment, okay? So you have this as the apothem. You have this as B over 2, half of it. This angle is 30 degrees, and this is the radius of the circle. So from here we can find, we can find our relationship. Okay, so remember the special angles. From the special angles, remember from the special angles that we did this in trigonometry. Trigonometry, you have in a 30, and we also did this in triangles. You have 60 here. If you look at my videos, we did this in a unit circle and also in triangles under geometry. This is 30 degrees. This is 2, this is 1, and this is root 3. So we see that what connects hypotenuse and this is the hypotenuse, this is the opposite, and this is the adjacent. So what connects hypotenuse and opposite? SOHCAHTOA 1. SOHCAHTOA 1. Okay? We did this in triangles, so you can look at it. So you now have that sine 30 is equal to opposite A over hypotenuse. Okay? So your A will be arrow sine 30 degrees. And from here, let's get our, from here, our sine 30 degrees is 1 over 2. Opposite over hypotenuse, 1 over 2. So A will be arrow times 1 over 2, which is arrow over 2. A is arrow over 2. The apothem. Radius over 2. Okay? Now what about the base? We have cos 30. Cos 30 degrees is adjacent over hypotenuse root 3 over 2. And please, you need to I didn't say this before now. Before you view this video, it is highly recommended that you have viewed, at least you know some triangles, the trigonometric ratios, okay, trig ratios, SOHCAHTOA, and then cosecant, secant, and cotangent. Okay, secant, cosecant, and cotangent. And also you know the unit circle, the trig ratios of the special angles. I did it on unit circle. I also did that on triangles. So please, it's important that you have that idea so that this will not be new to you. Okay, our cos 30 degrees is root 3 over 2. Okay, from this special triangle, 30, 60, 90 degree triangle. Or you can also say that in a 30, 60, 90 degree triangle, we mentioned this earlier in the previous video, in a 30, 60, 90 triangle, the hypotenuse is 2 times the short leg, and then the middle leg is root 3 times the short leg. Okay. Now from here, so we see hypotenuse radius over 2. From here also we now have adjacent and hypotenuse. So cos 30 degrees is adjacent is b over 2 all over hypotenuse is r. So b, we cross multiply, b over 2 is r cos 30 degrees. Okay? Multiply both sides by 2. So b is 2r cos 30 degrees. b is 2 times radius times cos 30 degrees. So let's get it. Let's get what it is. We now see that b is 2 radius times cos 30 degrees is root 3 over 2. So b is r root 3. b is radius times root 3. So when you're given the radius of the circle, you can find the apothem, you can find the base of the triangle. The base of the triangle right now is r root 3. Okay? And even also, when you're given the radius of the circle, you can see that from here, you can see that we see that A is r over 2. The apothem of the triangle is radius of the circle divided by 2. So the radius is 2 times apothem. Okay? 2 times the apothem. So even if you're given only the apothem, you can also find the base. You just substitute. That base is r is 2a root 3. That's it. That the base is 2 times the apothem root 3. And if you also, even if you're given the base, okay, the base or any side of the triangle, you can also find the apothem. You can also find the apothem. Apothem from here, apothem is b over 2 root 3. b over 2 root 3. You don't want to leave it like this, no. You want to rationalize. So apothem is b over 2 root 3 times root 3 all over root 3. So the apothem will be b root 3 over 2 times 3, which is b root 3 over 6. That is the apothem. If you're given the base. Okay? They need to give you just one thing, and you can find the rest. Okay, we need to find the height, and then we look at the area. So now, the height how can we find the height if we are given just the radius? This is what we will do. We will come and we are going to consider, if I call this, I can call this E. If I call this E. Considering, we can just consider triangle BED. Okay? Considering triangle BED. BED. So this is what we have here. We have a right triangle here. This is our perpendicular height. In this case, this is our perpendicular height. Okay? And this is half of the base, B over 2. That's half of the base. Meanwhile, we already know that B is R root 3 over 2. We already know that. And this is 60 degrees. This is 60 degrees. Okay? So, let's connect this is the opposite and this is the adjacent. So that is tan 60. So tan 60 degrees is opposite over adjacent, B over 2. So the height will be B over 2 tan 60 degrees. Okay? So the height is our B over 2. Our B is R root 3. Okay? R root 3 all over 2. Then times tan 60 degrees. Tan 60 here would be tan 60 degrees is opposite over adjacent. It's root 3. Okay? Tan 60 degrees is opposite of adjacent, root 3. So this is times root 3. So our height would be our height if I finish it here, our height would be r times 3 over 2. So our height is 3r over 2. 3r over 2. Okay? That's it. So, there are several ways. Even there's another way we can even get our height without even doing this. So many ways. Once you are given the radius, you can find all other things. And if you're given the A, you can find all other details. If you're given B, you can find all other details. You can. Do you know another way we can even get this? Or the apotem? Because if you look at this, the height is the radius plus apotem. You can see also that the height is radius plus apotem. And we know that the apotem is r over 2. See that? Apotem is r over 2. You can say that the height is radius plus apotem. Or the perpendicular height is this radius here plus the apotem, which is the radius plus A is r over 2. 1 plus 1 over 2. This is 3r over 2. You can also have it that way. Okay? You can also have it that way. Actually, And this also confirms that even if we, the 30 degrees that we started from is still right. Because even if you do it like this, 60 degrees, you still get back the same thing. Okay? And of course, your area of triangle, what is the area of the triangle? Area of the triangle is half base times height. Okay? Area of triangle is half base times height. Half base times height. And then the area of the circle is pi r squared. Pi r squared. Of course, by now, I hope you know that the radius is diameter over 2. Assuming they give you the diameter, to find the radius, you just do diameter over 2. And you get the radius. Okay, the next question they can ask you, I'm going to use this chalk here. The next question they can ask you is to find the area of the shaded part. They will give you, they will kind of shade this here, shade this here. And they ask you to find the area of the shaded part. Okay? And they might just give them, just give you only one thing. They can give you radius or base of the triangle, or the half base or height, or the apotem of the triangle. Any one they give you, they can just give you only one, and you find the whole thing. No problem. That is the way you do it. The area of the shaded part, look at the way this goes here. Because you have something like this. If you have something like this, let me just now erase this so I'll have space. You have this circle minus the triangle, because that is the area of the whole circle minus the area of the triangle. So you want to imagine this, that you put this triangle in the circle. So this remaining area is the area of the circle minus the area of the triangle. So I call that remaining area in my in this website. I call it remaining areas. So let's call this AR, remaining areas. Sum of remaining areas. Sum of remaining areas. Remaining areas. Okay? So this will be, AR will be AC minus AT, area of the circle. The whole circle here minus the area of the triangle gives you the sum of this area plus this area plus this area. That is the thing here. Okay? And then sometimes they might ask you to find one part. Area of each part. Let's call this, anytime you see a arrow, let's call it sum of remaining areas. And then AEP, area of each part. Let's call this area of each part of the remaining areas. Of the remaining areas. Area of each part of the remaining areas. Okay? So what will it be? It will just be AEP is equal to AC minus AT divided by 3, because you have 3 areas remaining. So area of each part is The area of the circle minus the area of the triangle divided by 3. And that's it. Whatever they give you, they just, like I said, they only need to give you one parameter and you find the rest. Okay? Let's go ahead now and do case 2. Case 2 will be circle inscribed in equilateral triangle. Circle inscribed in equilateral triangle. So, case 2 is circle inscribed in equilateral triangle. Or we can also say triangle circumscribed, equilateral triangle circumscribed about a circle. We can say equilateral triangle circumscribed about a square. Circumscribed about a circle, I mean. Not my name. About a circle. Equilateral triangle circumscribed about a circle. Okay. Let's see how this goes, folks. So we have something like this. Which one should I draw first now? If I draw the circle, as usual, don't mind my diagrams, okay? I'll try. I will try. So, case 2 looks like this. Circle inscribed in equilateral triangle. Okay, take down. Let's say center C. Let's call this also center C. Okay, as usual, let's call it center C. And we will have here as our radius R. And then from circle theorem. Now, there's something that you need to observe here. If they give you the radius, let's say given the radius of the circle, given R. Okay. We want to find everything. Want to find everything. And even the area of the shaded part as well. We want to find everything. So this is not drawn to scale, okay? Of course, from here you know that the area of the shaded part will be the area of the triangle minus the area of the circle. Here we actually have 3 tangents. We have tangents to circles here. Let's call this A. Let's call this B. Let's call this D. Let's call this E. Okay? So we have the tangents to the circles. We have line segment AB is a tangent to the circle. Line segment BD is a tangent to the circle. Line segment AD is a tangent to the circle. Okay? And if you want, we can call this here A, B, C, D, E, F. We can call this F here. Okay? We can call this G. Okay. So line segment AB is tangent at point F. Point F is the point of tangency or the point of contact. Line segment BD is tangent to the circle at point G, the point of contact or the point of tangency. And line segment AD is tangent to the circle at point E. E is the point of contact or the point of tangency. And we know that from circle theorem that radius is perpendicular to tangent at point of contact. Okay? This is a theorem. Radius is perpendicular to tangent at point of contact, at point of tangency or point of contact. Okay. We call it point of tangency or point of contact. Radius is perpendicular to tangent at point of contact. Okay. Another thing you see here is you have, of course, you have this is a equilateral triangle. This is a regular triangle. So this is 60 degrees, 60 degrees, 60 degrees. Okay? You do have this. An important thing on the theorem of circles, you have that if you have two tangents from the external point D, okay, if we consider considering, we can write this, considering tangents BD and AD. What is the external point? External point is D. You write it. Okay? You can also write, if you want to consider tangents AB and AD, the external point is A. Tangents AB and BD, the external point is B. Okay? Right? So, one of the circle theorems, okay, you have to do the videos on circle theorems as well. One of the circle theorems is that two tangents drawn from the same external point, number one, they are equal in length, they are congruent, the two tangents. From this point of contact, from GD is equal to ED. Okay, GD is congruent to ED. Okay? Reason, okay? Two tangents drawn from the same external point are equal in length from their point of contact. Okay, two tangents drawn from the same external point, you can write down the reason. Okay, write it down. Two tangents, let me write it. Two tangents drawn from the same external point are congruent. Okay? That is this point of contact from there. Okay, they are congruent. So, and also that is number one. Number two, the line from the center of the circle to the external angle. That line, the line, of course, we have radius is perpendicular to the tangent and point of contact. We want to consider tangents BD and AD. So we see first the radius is perpendicular to tangent and the point of contact E. Then these two tangents from their point of contact, two tangents drawn from the same external point, GD is equal to ED. Okay? That's 2. Now number 3. If we draw an angle from here, if we draw a line to this here, it bisects this angle. It bisects the angle. It bisects the angle. It does. And also here, another one, because this is also the radius here. This is a radius. At their point of contact, this is also a radius. This is also a radius. So first thing, number 1, the radius is perpendicular to tangent. That's 1. 2, the two tangents drawn from the same external point are equal in length. That means their point of contacts to the distance from their point of contact to the external point. Okay? It's just like if we're considering this, if we're considering AB and AB, then we say that AF is equal to AE. AF is congruent or equal to AE. So GD is congruent to ED. Also, the line from the center of the circle to the external point bisects the angle formed by the external point. Okay, this is 90 degrees here. Radius is perpendicular to tangent. 90 degrees. This is 90 degrees. And also, number 4, the angle here, the central angle, okay, this angle is equal to this angle. I'm going to use double lines to tell you they're equal, because I use single lines here. So angle, we see that angle GDC, angle GDC is equal to angle EDC. Also angle GCD. I don't mean greatest common divisor, okay? Is equal to angle BC or EDC. Okay? Angle GCD is equal to angle ECD. ECD. Okay? Angle GDC is equal to angle EDC. And also angle GCD is equal to angle ECD. That is when you have two tangents. Some textbooks call it two tangent theorem. Okay, so you will need to build circle theorems and understand it, and this will make more sense to you. Okay? Now, remember we're given the radius of the circle. Okay, let's now find the other details. Remember, this bisects it. So, and in an equilateral triangle, you have 60 degrees. So, it bisects it, this is going to be 30 degrees. Okay? And then if we consider the whole diameter, we have the 60 degrees. If we consider the whole diameter. But for the radius, we're going to use 30 degrees. But if we consider the whole diameter, then we're going to use 60 degrees. But we are given the radius, so let's start from there. Even if you're given the diameter, let's get the radius. You can do diameter divided by 2 to give you the radius. Okay, so let's go ahead and find the other details here. And you can convert, once you get that, you can convert. You know, you can now substitute to get other ones. So we have something that looks like this actually, folks. We have something that looks like this here. This here is 30 degrees because the whole of here is 60 degrees and this bisects it. So it's 30 degrees. This is our radius r. Okay? And this is b over 2, the base. b over 2. This is a right triangle. Remember the other one we did was apotem. Okay? But this one, this is the way it will look. Okay? The radius here, and then the base over 2, and then this is 30 degrees. Okay. So what connects, this is opposite and this is adjacent. So tan 30 degrees is opposite over adjacent, b over 2. So actually we are giving r. We are giving r wrong. Let's find the b, let's find the base. Okay? Let's find the base. One thing you have to note, please, let me say this. You write, you also include this, please, so, and then we continue. This is a bigger fraction, and this is b over 2. Okay. So please, one thing you have to note is when you have this case 2, of course, as usual, the center of the circle is the center of the triangle. Okay? You have to also include this in your notes. Okay? You also include this. The diameter of the circle is the perpendicular height of the triangle. Okay? The diameter, sorry, I take it back. Not the diameter, I'm sorry. Not the diameter of the circle, I'm sorry. Because the diameter of the circle is from here. Yeah. So please, we won't do that. Okay? We won't do that. This whole, no, I take it back. But what you have to write is that the apotem, the radius is equal to the apotem. Okay? The radius is equal to the apotem. That is one thing you have to include. Okay? That is one thing you have to include. That the radius of the circle is the apotem of the triangle. Okay? When you have the circle inscribed in the equilateral triangle. Okay, later we will talk about the diameter. Okay? But the diameter is not the diameter is not the perpendicular height. No, it's not. But we shall talk about it later on. Okay? So let's go ahead. The base over 2 tan 30 degrees is your r. Remember, you're given r and you want to find the base. So base over 2 is r all over tan 30 degrees. Okay? We divide both sides by tan 30 degrees. So this means that you multiply both sides by 2. Base is 2r over tan 30 degrees. Base will be 2r over tan 30 degrees. Which will give us what? 2r over, now, tan 30 degrees is opposite over adjacent, 1 over root 3. Okay? So 2r all over 1 over root 3. So this means 2r divided by 1 over root 3. That is what it means. So the base is 2r times root 3. So the base is 2r root 3. That's your base. That is your base. Okay? 2r root 3. The base of the triangle. Now let us get the height. Let's get the height. We were given the radius of the circle, but we now have the base. Okay? Let's go ahead and get the height. For the height, we are going to consider triangle considering triangle BED. Okay, so this is what we have here. Triangle BED. The perpendicular height is this. The perpendicular height. Okay. This is our base here. Our base 2r. This is our base. Base over 2. B over 2. B over 2. I kind of need some space here. Perpendicular height, and this is our B over 2. Yeah. Okay? And this is 60 degrees. No longer 30 degrees, but 60 degrees. Okay? This is opposite over adjacent. So tan 60 degrees is opposite height over adjacent, B over 2. So the height is B over 2 tan 60 degrees. So the height will be, meanwhile our B is 2r root 3. 2r root 3 all over 2 times tan 60 degrees is root 3. It's root 3. Bam, bam. So the height will be r root 3 times 3. Root 3 times 3 is 3. R times 3. So our height is 3r. Remember, the diameter is 2r, but the height is 3r. Our diameter, of course, is 2r, but our height is 3r. 3 times the radius. That's the perpendicular height of the triangle. Okay, and you can find, the A is the arrow. Our A, our apotem is the radius also. And you can find, that's the nice thing, you can find any of these. Like if they give you the radius. You've already, the apotem, you now know the height, the perpendicular height, and you know of course the diameter, and then you know the base of the triangle. Okay? You can, if they give you the height, you can find the radius of the circle, you can find the base, and the rest of them. What else do we need to find now? We found almost everything. Now, the area of the triangle and the area of the circle, okay, the same way we've done the same way we did the previous one. Area of the triangle is half base times height. Okay? Area of the circle is pi r squared. And as usual, area of the shaded part is area of the triangle now, minus area of the circle. So sum of areas remaining, AR. Some of the remaining areas is area of the triangle minus area of the circle. And then the area of each part, AEP. Area of each part is area of remaining all over 3. The next thing we are going to do before we call it a night is let's express all these things in terms of arrow. Okay, let's express all these things in terms of arrow. So in the case one that we did, okay, triangle inscribed in circle, triangle inscribed in circle, we saw that the base was arrow root 3 and h was 3 arrow over 2. We just did that. H is 3 arrow over 2. And then for the case 2, circle inscribed in triangle, circle inscribed in triangle, we see that B is 2 arrow root 3 and H is 3 arrow. Okay, so let's find a lot of details based on this. So the area of the circle AC, of course, is pi arrow squared. Area of the triangle is half base times height. Half base times height, which will give us half. Base is arrow root 3 times height is 3 arrow over 2. 3 arrow over 2. So this will give us what? That the area of the triangle is 3 arrow squared root 3 all over 4. 3 arrow squared root 3 all over 4. Okay? That is for this. We found area of the circle and then area of the triangle. Let me circulate. And when we have circle inscribed in triangle, we see that the area of the circle also is pi arrow squared because they gave us the arrow. Let's put all this in terms of arrow. And even if they give you the diameter of the circle, just divide it by 2 to get the radius, and you can find all these, any one they give you. I'm not using the apothegm this time because I'm interested in the areas, okay? But even if they give you only the apothegm, you can still get the radius. So area of the circle is pi arrow squared. Area of the triangle is half base times height. Half base times the perpendicular height. So area of the triangle is a half times the base here is 2 arrow root 3 times the height is 3 arrow. And we can cross out. Bam, bam. So we have that the area of the triangle is 3 arrow squared root 3. 3 arrow squared root 3. And let me go ahead and circle this. Okay? Now, sometimes they might ask you to find the ratio of the areas. Okay, they might just give you arrow. They might give you the radius of the circle. And they ask you to find the ratio of the area of the circle to the area of the triangle. Remember, this is equilateral triangle. This is equilateral triangle. Okay, let me write it here so that you don't just think it's any triangle. Equilateral triangle. Because that is the regular polygon, regular triangle. Okay, so let's go ahead and find area of the circle to the area of the triangle. Area of the circle to the area of the triangle. So we have area of the circle is pi arrow squared. divided by area of the triangle is 3r squared root 3 over 4. So this means pi r squared divided by 3r squared root 3 all over 4. So this will give us pi r squared times 4 over 3r squared root 3. Okay, so we have that our r squared crosses us r squared. And we now have 4 pi over 3 root 3. Well, we don't leave it like this. We need to rationalize. So this will be times root 3 all over root 3. And that will give us 4 pi root 3 all over root 3 times root 3 is 3. 3 times 3 is 9. And this becomes our answer here. 4 pi root 3 over 9. That's it. Okay? That's it. 4 pi root 3 over 9. And sometimes also they can ask you area of the triangle over area of the circle. They can also ask you that. So we could just flip this and then finish it up. It doesn't matter. Area of the triangle over area of the circle. Or you can do it from first principle. Or you can just flip this. But let's do it from first principle. This is 3r squared root 3 over 4 times divided by pi r squared. Okay? So this will give us, if we finish it here, this will give us area of the triangle over area of the circle would be 3r squared root 3 over 4 times 1 over pi r squared. So the radius crosses out, and we now have 3 root 3 over 4 pi. 3 root 3 over 4 pi. And that becomes your answer. Now if you wanted also, you can flip this. You could also have flipped this, but you will need to rationalize. We could also have flipped that 9 over 4 pi root 3. Like you flip it, because this means AC over AT is 4 pi root 3 over 9. You could also, if you want to find AT over AC, you could flip it. Okay? And you will have this, and you just rationalize times root 3 over root 3. And this will give us 9 root 3 over root 3 times root 3 is 3 times 4, 12 pi. And then you simplify. And you have 3 root 3 over 4 pi. Okay? The same thing. Okay, then here, case 2, if we find area of the circle to the ratio of the area of the circle, and this usually happens, they just give us the radius of the circle, or they might give us the diameter of the circle, and then we have to find the radius and do it this way. So if they ask us to find the ratio of the area of the circle to the area of the triangle, okay, equilateral triangle. So this will give us pi r squared all over 3r squared root 3. And r squared crosses out. So we have pi over 3 root 3. And we need to rationalize, okay, times root 3 over root 3. And that will give us pi root 3 all over 3 times 3, 9 all over 9. And this becomes our answer, pi root 3 over 9. If you now want to find area of the triangle, the ratio of the area of the triangle to the area of the circle, okay, that would give us 3r squared root 3 all over pi r squared. And this gives us what? R squared crosses out, and we have 3 root 3 over pi. 3 root 3 over pi. That's it. Okay? We could also flip this, and if we flip it, we will still get the same thing if we rationalize. Okay? If we flip this, if we flipped 9 over pi root 3, this will give us 9 over pi root 3 times root 3 over root 3, and that will give us 9 root 3 over 3 pi, because root 3 times root 3 is 3, and 3 goes into 3, 1, 3 goes into 9, 3. So this will be 3 root 3 over pi, the same thing. Okay, I hope we've covered a broad range of questions that they can ask you based on circle inscribed in equilateral triangle, and also equilateral triangle inscribed in circle. You will see the formulas for these formulas you can see it under the geometry notes on my website, or you can also see it under the notes section of this website. Okay? If you feel that there is nothing if you feel there is something more to be covered, just let me know. Okay? Thank you so much for listening.